Hi, I'm Elizabeth from Logic Walk. Last lesson, we learned how network devices help us share information between computers. Now, let's see how that maps into our Logic Walk simulator. Just like with a hard drive, sending data to a network device happens in two steps. First, the computer writes its data into designated memory cells, called the network buffer. Then the computer signals the network device when it's ready. To receive data, the network device writes the incoming data into the destination's computer network buffer and then triggers an interrupt to notify that computer. The key difference is that a hard drive always moves data only between itself and its own computer, while the network device transfers data from one computer to a different computer. For this to work, the sender must include the destination address so the network device knows where to deliver the data. Let's see a network device in action in the Logic Walk simulator. Our setup now includes two computers, computer A and computer B, plus a single network device, network A, and a display attached to computer B. In this program, computer A will send the message "Hi B" through network A, and computer B will print it on the display. Let's see this in action. When we run the program, "Hi B" gets printed on the display just as we expected. Now let's dig into how that happens. Because this program involves two machines, there are two instruction sets to examine. First, we'll walk through the instructions for computer A. Computer A sends its message by first loading it into its network buffer, which spans cells 50 through 65. In this program, instructions 0 through 4 write the characters of "Hi B" into cells 50 through 54. Then instruction 5 records the data size, 5, in cell 66. And instruction 6 saves the destination address using the ASCII code for B in cell 67 to mark computer B as the receiver. Once the buffer and addresses are set, instruction 7 signals network A that the data is ready to send, and instruction 8 places the computer into an idle loop, waiting for the network device to process the message. Network A remains idle until it receives a signal from computer A. When that signal arrives, it performs the following actions. It copies the data from computer A's network buffer cells 50 through 54 into the same buffer cells 50 to 54 on computer B, then alerts computer B by turning interrupt cell 2 on. Computer B stays idle at instruction 0 until it receives the interrupt from network A. As soon as it's interrupted, the program counter jumps to instruction 3, which enters a loop that copies each character from the network buffer, cells 50 to 54, into the display buffer, which are cells 10 through 14. This loop continues until the display data size matches the network data size. Once all characters are transferred, instruction 14 turns on memory cell 26 to signal the display, and the display prints the message. Now that we have reviewed the network data transfer at a high level, let's take a closer look at how the simulator state changes as data is sent from one computer to the other.